It's a story of innovation born from the iciest conflict in history, the Cold War. Picture this. The world is on edge. Two superpowers are locked in a silent standoff, and the battleground isn't always what you'd expect. Sometimes, it's a frozen wasteland, a desolate Arctic landscape, or a strategic airfield buried under feet of snow. For both the US and the Soviet Union, controlling these frigid frontiers was a matter of national security. An immobilized air force or a blocked supply route could mean disaster. This urgent need sparked a technological arms race, but not just for missiles and spies. It was an arms race for mastering the cold. This is where our story begins, in the unseen battlegrounds of the Arctic Circle and the windswept plains of Siberia. Military engineers faced an unprecedented challenge: how to keep massive, mission-critical infrastructure operational in the most extreme winter conditions imaginable. Traditional snowplows just couldn't cut it. They needed something faster, more powerful, and more reliable than anything that had ever existed. They needed machines that could clear a 2-mile-long runway in under an hour, not days. The stakes were incredibly high. A grounded bomber fleet due to a blizzard was as much a threat as an enemy missile. So, they started experimenting, pushing the boundaries of engineering. The solution they came up with was radical, and frankly, a little bit terrifying. They looked at their most powerful technology, the jet engine, and thought, what if we repurposed it? Instead of propelling a plane through the sky, what if we used its immense power to blast snow and ice into oblivion? And so, the first jet-powered snowblowers were born. The Soviets were pioneers in this, famously strapping Klimov VK-1 jet engines, the same ones that powered the legendary MiG-15 fighter jet, onto the chassis of heavy trucks. These mechanical beasts, known as snow-melting machines, would roar to life, spewing a jet of superheated gas at over 1,000 degrees Fahrenheit. The result was pure, unadulterated power. They didn't just move snow, they vaporized it, clearing railway lines and airfields with brutal efficiency. Imagine the sight and sound of one of these things in action. A deafening roar that would shake you to your bones. A plume of steam and melted snow rising into the frigid air. It was a spectacle of raw power. On the other side of the Iron Curtain, American engineers were working on similar concepts. They mounted surplus jet engines on everything from railroad cars. But the jet engine was just the beginning. The military's demand for efficiency drove advancements in other key areas, like hydraulics. In the Cold War, hydraulic systems became more robust, more powerful, and more precise. They had to operate missile silos, aim heavy artillery, and control the complex flight surfaces of supersonic jets. This advanced hydraulic technology was a game changer. When it transitioned into the civilian sector, it fundamentally transformed snow removal equipment. Suddenly, plows could be angled with incredible precision, and wings could be deployed and retracted on the fly, all with a simple push of a joystick. This new level of control allowed a single operator to do the work that once required a whole team. They could maneuver massive plows through tight city streets, around parked cars, and up to loading docks with an accuracy that was previously unthinkable. The powerful hydraulics also enabled the creation of much larger and more complex plows. Think of the giant, articulated V-plows you see on highways today, capable of carving a path through massive snowdrifts. Their ability to change shape, from a V to a straight blade to a scoop, is a direct legacy of the advanced hydraulic systems perfected during the Cold War. It's all about leverage and power, principles honed for military application and now used to keep our cities moving. Another critical area of development was metallurgy. Cold War aircraft and vehicles had to withstand incredible temperature extremes, from the heat of a jet engine to the sub-zero chill of high-altitude flight or Arctic deployment. This led to the development of new steel alloys that were incredibly strong yet remained resistant to becoming brittle in the cold. When these advanced materials became available to civilian manufacturers, they revolutionized the durability of snow removal equipment. Plow blades, made from a carbon, hardened steel could now smash through compacted ice and absorb impacts that would have shattered older blades, all while resisting wear and tear for much longer. This meant less downtime for repairs and more time on the road clearing snow. It's why a modern plow can operate relentlessly, shift after shift, through the worst winter storms. The very molecular structure of the steel in that blade is a product of the Cold War's demand for materials that could perform in the harshest environments on Earth. It's a hidden strength, an invisible legacy that makes our modern snow management system so incredibly resilient. Every time you see a plow blade scraping against the asphalt, sending sparks flying, you're witnessing the legacy of Cold War metallurgy in action. So, how did all this top-secret military tech make its way to your city streets? It happened through a process called technology transfer. As the Cold War thawed and military budgets shifted, many of these technologies were declassified and became available to the commercial market. Entrepreneurs and established companies saw a golden opportunity. They took these battle-hardened concepts, the power of jet engines, the precision of advanced hydraulics, and the durability of new steel alloys, and adapted them for civilian use. The market was hungry for better solutions. Growing cities and our reliance on just-in-time logistics meant that a snow day was no longer a quaint inconvenience. It was an economic disruption. Companies like Oshkosh, originally a builder of rugged, all-wheel drive military trucks, applied their expertise to create unstoppable airport snowblowers. Others refined the jet engine concept, moving away from pure heat and focusing on airflow. Instead of melting the snow, they designed massive, multi-stage turbine blowers that could ingest enormous volumes of snow and cast it hundreds of feet away. These are the titans you see clearing airport runways today. Machines that can throw over 5,000 tons of snow per hour. They are the direct descendants of those crude, jet engine on a truck contraptions, refined and perfected for a new mission, keeping the global economy moving. Today, the legacy of this Cold War innovation is everywhere. Look at a modern airport snowblower. That massive, articulated chute that directs the snow. Its precise control is thanks to military-grade hydraulics. The powerful augers that chew through dense, compacted snow and ice. They're forged from steel alloys, developed to withstand extreme stress and cold. The multi-stage fan that throws the snow with incredible force and accuracy. Its design principles are rooted in jet turbine technology. These machines are not just bigger plows. They're sophisticated, integrated systems, each component a testament to an era of intense technological competition. And it's not just at the airport. The same principles have trickled down to the municipal plows clearing your streets. The combination of powerful engines, advanced all-wheel drive systems, sophisticated hydraulic controls, and durable materials allows cities to fight winter on a scale never before possible. It's a coordinated, high-tech battle, and the weapons being used were forged in the crucible of the Cold War. It is a fascinating example of how technology developed for conflict can be repurposed for the public good, creating a safer and more efficient world for all of us. The next time you're stuck in traffic, watching a convoy of plows work to clear the highway, take a moment to appreciate the hidden history behind those powerful machines. You're watching the peaceful dividends of a once frozen war. Thanks for watching, and do you forget to like and subscribe for more amazing stories behind the technology we use every day.